All right. Yeah, y'all can see that. All right, so let's look at 45. Okay, we really didn't get through it too well. All right. Let me look at the two functions. Okay, they were square root functions. F of x was equal to the square root of x plus 4. And then g of x was square root of x minus 1. All right. Now, let's look at f plus g. Okay. Now, so let me remind you. I want you to picture this in your head. All right. What if I have the square root of 2 plus the square root of 3? Let me write down real quick. You can't combine those, can we? Okay. So if I had this though, if I had square root of 3 plus square root of 3, now what would that be? 2 square roots of 3. Okay, does that make sense? 2 square roots of 3. Because that's like what? 1 square root of 3 and 1 square root of 3 is kind of like x plus x is 2x. Okay, now what about this? Back to 2 and 3. What about square root of 2 times square root of 3? Square root of 6. Okay. Now, let me do this to see if this will help. Go ahead. Is that any better? A little bit. All right, let me erase this. Don't erase as good as the other one. We've got another app where all you have to do is like circle it and then tap it, like the smartboard. This one writes better. All right. Now, so what I'm getting to here, all right, let me write it down. Square root of x plus 4 plus the square root of x minus 1. Okay. Can I like say that's like 2x, square root of 2x plus 3? No, that's it. Okay, I can't combine them. Now, for time's sake here, I'm going to skip over f minus g. The only thing that would change with f minus g is this right here would change to minus. And that's it. Okay? Now, let's go to f times g then. So f times g, all right, let's multiply them. Square root of x plus 4 times the square root of x minus 1. Now, can I leave that one like that? No, because you can actually multiply that. Okay? So we'll multiply this. It's going to be under a big honking square root here, still. All right, but we could FOIL this out, couldn't we? So x times x is x squared. Now, I'm going to do outside and inside in my head, if that's okay with y'all. So, what? Negative x plus 4x would be 3x. Okay? And then 4 times negative 1 is negative 4. Okay, and that's it. All right, so all I did is multiply them out, and I just kept them under the square root. All right, now, what about, let's see, what's left here? F divided by G. No, I mean, we'll find the domains at the end. Okay, so here's the thing, though. About the domain, do I need any of this for the domain? What do I need to look at for the domain? The original problem. This and this. I don't need any of this junk right here for the domain. Okay? Now, if that's okay, I'm going to erase this right here, okay? Is that alright? You got it? It's going to take a little bit. Probably should have just... I'm not too good at erasing here. How about I just start over and rewrite the functions. All right, here we go. 45. All right, help me out. What was F? All right, and then G was. All right. Okay, now we're in division, right? So we're going to do F divided by G. Okay, now here's where we're going to run into a little bit of trouble. We got F here is square root of x plus 1. Is it plus 4? Okay. Alright, and then G is the square root of x minus 1. Okay, now let's talk about, can I leave that and just be done with it?
You can't have radical.
Right, can't have a radical in the denominator. It's not the simplest form. So what's that process of getting rid of it? Whatever's on the bottom. Okay, so let's do an easy one real quick to review. So if I have 2 over the square root of 3, we multiply by the square root of 3 over square root of 3. So we would get 2 square roots of 3. Now, square root of 3 times square root of 3 would just be square root of 9, which would just be 3. Alright, now we're going to do the same thing, except for with what we have. Go away, little dot. Go away, little dot. Alright, here we go. Alright, so we need to multiply by what here? Square root of x minus 1 over the square root of x minus 1. Okay, alright, I'm going to do the bottom. That's right, I said it. I'm going to do the bottom. Because that's just going to be x minus 1. Is that okay, everybody? Now, so we got to multiply out the top, don't we? Okay, now, didn't we just do that? Alright, so you could just look up at the previous problem and get this part, right? So this would be the square root of, what was it, x squared plus 3x minus 4, was that right? Okay, now somebody asked me in second period, do we maybe need to factor this back out so we can cancel? But the answer is we can't cancel that. You'll kind of realize why we can't. Right, very good. It's under the radical. Okay, so that's it. That's F divided by G. Now, let's look at the domain. All right, let me write down my functions again. Help me out. What were they?
X is square root of x plus 4. And
Okay.
X is square root of x minus 1.
Okay, thank you. All right, so now, when it comes to the domain, I don't have to pay attention to any of the work. All I have to do is pay attention to the functions. Okay, now watch this part real close. Okay, so F plus G, F minus G, and F times G, the domain's going to be the same thing for all three of them. Okay, so y'all remember what the domain was? The notation for it would be what? The domain of F intersect domain of G. Now, let's talk about the domain of F and the domain of G. So y'all think about them just a minute. All right, they're square roots, aren't they? So square roots can't be negative. So what has to be true about this x value here? Right, greater than negative 4, or can it be greater than or equal to negative 4? Greater than or equal to, because it's okay for the square root to be 0, isn't it? All right, so the domain there would be, for F, would be x has to be greater than or equal to negative 4. Now, what about the domain of G? Right, greater than or equal to 1. All right, now, so how are we going to find the intersection of those two? Number lines. Yeah, and so with interval notation, you're right. Okay, so you remember, this is why we did that first lesson like this. And so when you got to this, you would know what to do. So I'm going to draw two number lines because it's the intersection. Remember, a union, all you need is one number line. But here I need two of them. So negative 4, 1, negative 4, 1. All right. So let's do greater than or equal to -4. Y'all want to use open and closed circles or brackets and parentheses? Brackets, okay. Let's do this. That would be greater than or equal to -4. Now greater than or equal to 1 would just be this part. All right. So now, what's the intersection from 1, to infinity? And y'all said with a bracket, right? Okay. So there's our domain. Finally. Okay. Now, is that the domain for all 4? No. Okay. So f divided by g has the same thing, but we have to say a little bit extra. Let's see. So f over g, all right, that's the same thing. It's domain of f intersect domain of g, and not x can't equal 0, but g, the g function, cannot equal 0. So we need to look up at the g function, which is up here, and figure out what value of x would turn the g function into 0. 1. Okay? So the domain of f divided by g is going to be this, except for x can't be equal to 1, so we need to use a parenthesis to exclude it. Does that make sense? Okay? So now my domain there is 1 to infinity. Okay? All right. The other one that you're going to do is just like that. Now, what we're going to do today, I'm not going to go on to composition. That's what we're going to do. We're just going to put that off till tomorrow. So, what I want you to work on, if you hadn't fixed number 45, be sure that you fix it. All right. But you can still do from tonight's assignment. All right, 36, 42, and 46. Okay, that's for, what's today, Thursday? So we're moving the composition down to Friday. I'm not going to move the review down another day. Okay, so we'll just have to play a little catch up on Friday. Okay, all right, so y'all fix number 45, and now y'all go back and try these too. Okay. No, but I'll write them up on the board over there for you, okay?